Welcome back to electrochemistry class. So, let us look back what we have studied so far in this few lectures. So, if we look at the topics that are expected to be covered in this series of lectures are like conductance in electrolytic solution that we have taken up in details, and we have also tried to explain how this conductance of solution will vary due to several factors like concentration, maybe like dilution and maybe temperature. In this regard, we talked about also specific conductance and specific and molar conductivity. Then we also discussed this variation of conductivity with concentration, and important thing, that important concept we have learned over here is Coleridge's law of independent migration of ions, that at infinitely dilute situation all the ions are free to move, and there is probably most likely there is no interionic attraction, that is ionic attraction is minimized and ions can freely move, and therefore molar conductivity of an electrolyte, that is basically molar conductivity, sum of the molar conductivities of the constituent ions. Then we have tried to learn electrolysis. Electrolysis means it is electro means while you apply some electricity from outside through a pair of electrodes, then your material is lysed, that is broken down into pieces like water. If you electrolyze, it is broken down into pieces like hydrogen and oxygen, that in that case you need to supply electricity from outside, means you need to supply energy, so that the reaction, this breaking reaction, lysis reaction can take place. And also we talked about this laws of electrolysis, that is Faraday's law of electrolysis. Just we gave the elementary idea. Then we also talked about this dry cells like Leclanche's cell. Then also we talked about this electrolytic cells, then galvanic cells, then lead accumulator, that is lead acid cell, lead acid battery, which is used in like in car, etc. Also we have talked about electromotive force of a cell, and electromotive force is nothing but the reversible cell potential when you draw zero current from the cell, then the cell reaction, net cell reaction becomes, the cell reaction or the electrode reaction become reversible, that is perfect reversibility condition is maintained, and therefore thermodynamics of reversibility, reversible thermodynamic principle can be simply applied to that. And we also talked about standard electrode potential, that standard electrode potential is the potential when activity of the electroactive substance is unity, or maybe it is 1 molar at 1 molar concentration, or maybe unit concentration. Then you also used Nernst equation, although derivation was not done over here, just the statement of Nernst equation that connects the cell potential with the reaction quotient of the reaction that is involved in the cell. And also we have discussed a number of applications in connection with this electrochemical, this EMF measurement like pH of the solution, how pH can be measured using EMF measurement, or maybe how can we follow the precipitation, I mean this redox reaction, that we also have discussed over here, and also how to find out this solubility product of a sparingly soluble salt, and that we discussed in the light of this EMF measurement. Now, how EMF can be measured? It is not with the help of a voltmeter, but it is a basically a potentiometric measurement where you draw zero current. So, it is called the Poggendorff's compensation method. So, Poggendorff's compensation method has been applied to determine the EMF of the cell. Various types of electrodes, I mean half cells, were also considered, and we also attempted construction of this of cells, okay, construction of cells based on the requirement, based on the net reaction. We have given one or two example of that. Then we found out the relation between the Gibbs energy change and the EMF of the cell. Okay. These are the things that we have covered so far. Now, some more things are yet to be covered over here. First of all, one is fuel cell, another is corrosion. These are the two important aspects, and maybe we will just talk a little about redox reaction, because this electrochemistry basically deals with this. It is nothing but the redox reaction. I mean it is an electrode process. Okay, it is the redox reaction. So, therefore, what is happening, that when you construct a cell, when you construct an electrochemical cell, then there occurs some chemical reaction, and at the electrode what is happening, that in one electrode there will be oxidation, and in the other electrode there will be reduction. Now, I already have discussed this point, that when you dip one metal in its electrolyte solution, then either the metal has the tendency to accept electrons from here, from this, and it will become more negatively charged, or it will acquire more negative potential over here, and this one becomes positive, or in other words, this metal will lose electron and then it will get dissolved over here. Okay. In this way, this acquires a negative potential with respect to this solution, and the reverse may also take place, that you have the electrode which is dipped into the electrolyte solution, and what will happen, that the ions over here will accept electron from here and get reduced, and it will be deposited onto this metal. So, in that case, that case it will become your positively charged. So, when you connect these two, then it will form an electrochemical cell. Only thing is that while constructing this electrochemical cell, you have to keep this in mind, that your net cell potential will be greater than 0. If it is greater than 0, means the cell reaction as represented for this E cell will be spontaneous, that is delta G will be negative, that is reaction will be spontaneous in the direction shown with respect to this E cell greater than 0. So, redox reaction means basically in case of redox reaction, what we do, that we pick up a specific redox reaction, and then what happens, that we dip one electrode in that redox couple, so that this redox reaction is taking place by means of the fact that this electron exchange will occur through this electrode, and as a result of which one electrode will acquire some positive charge and the other electrode will acquire some negative charge, and when these two are connected, that means the relative potential of these two, relative potential of these two are same. So, therefore, with respect to this one it is negatively negative, it will acquire some negative potential and this will acquire a positive potential. Therefore, from external source if you connect with a with wire, then current will flow from this direction, from here to here, and electrons will flow like this. So, therefore, this redox reactions are very important. So, if there is no redox reaction, then if it is, say for example, say a precipitation reaction, say for example, AgNO3 plus Cl minus, that gets you AgCl plus nitrate minus. So, directly you cannot, since it is not a redox reaction, you cannot form a cell like this, but what you have to do, you have to have an indirect way of measuring the parameters for this reaction, that you will construct a redox process such that the net reaction will be like this. So, therefore, redox reactions are of immense importance as far as this electrochemistry, study of electrochemistry is concerned. Next is another important thing that we should keep in our mind, that while we were discussing this electrolysis, what happens that you have two electrodes and you apply some potential difference between these two electrodes. So, it is grossly stated that negative ions will be attracted by the positive electrode and negative ions will be attracted by the positive electrodes and positive ions will be attracted by the negative electrodes. So, that generally happens when these ions are in close proximity to the electrode, so that it can fill the potential gradient. But if this one is placed at a very long distance, then practically this ion has the option to move in any direction. In any direction means it can move in this direction or that direction. Okay. So, but those ions, those negative ions which are close to this electrode will be attracted, and if the potential is such that this electron transfer is favorable, then this ion will be discharged. I mean, this ion will lose one electron over here, and then it will be discharged. In the same way, this will happen for the plus. So, therefore, discharge is taking place, or the redox process is taking place very close to the electrode, but here it has got the provision to move randomly. But statistically what happens, that if these ions are converted to their corresponding discharged counterpart, then on an average the concentration of the negative ions will be reduced over here. The system will face a concentration gradient, there a concentration gradient will be produced. So, in order to equilibrate this gradient, I mean in order to minimize this gradient, again negative ions will be coming in the vicinity of this. So, this way things will happen, and net effect is that as if the negative ions are attracted by the positive electrode from any position. So, it is not as simple as that. So, only there when these ions face the potential difference or a potential of this electrode, only that happens when this is coming at some appreciably close separation, because so that it can fill the field. Otherwise, at a larger separation you may not be able to, or the ion may not be able to fill the field. So, these are the few things that you should remember. Next, we will let us turn our attention to those two topics. One is this fuel cell and the other one is corrosion. Fuel cell. Now, we have learnt cells. Cells means the device that can supply electricity, like the battery or the lead accumulator or lead acid cell, that is PbO2, this thing. Now, what happens that in case of normal cell, like say for example, Leclance's this dry cell, we have discussed this point that this dry cell is good until all the reactants are exhausted, or you cannot keep this dry cell for very long time. This is because of the fact that this will discharge, there will be a self discharge, that is there is internal resistance. So, electricity will flow across the electrodes against that internal resistance, and it will automatically get discharged if you keep the cell for a long time, and that is also going to happen in case of this lead acid accumulator, that there also internal discharges is possible. So, therefore, so these electrodes, I mean these cells are good until the chemical substances are available over there. I mean those chemical substances which are involved in the chemical reaction to produce the electrical energy. So, therefore, so supply of electrical energy from the chemical reactant, basically from the chemical reactant is stored within this cell, and then what is happening, that reactants are consumed, and one situation will happen that all the reactants will be consumed. So, what will happen then, if all the reactants are consumed, then nothing is remaining. So, the cell reaction is not going to proceed any further. Proceed any further means no further cell reaction will take place. So, cell will stop functioning. So, cell will become dead. So, when reactants are consumed, cell will become dead, and then what do? We throw the cell away. We go to the market, we buy new sets of cells, and then plug in those cells in the appropriate device. So, therefore, there is no way to reuse the cell, or at least the outside, I mean the cover of the cell. Okay. What happens in case of your lead accumulator? You can recharge it, and then you can use it again. So, a number of cycles can be used for recharging again and again, but here it is not possible. But suppose if the situation is such that there is a mechanism by which you can take out the used chemicals, and then you can feed the cell with a new set of chemicals, unreacted chemicals, then what is going to happen? Then you can expect the cell to gain its power again. That means, cell will start to work again. Okay. So, that is why as if you are I mean this thing means as if you are fueling the cell, like you fuel your motorcycle or you fuel your car. You go to the gas station and pay money, and then you fuel it. Fuel it means either you put petrol or diesel in the fuel chamber or fuel tank. So, that means when once this fuel in the fuel chamber is exhausted, you put new fuel in, and then the system will continue to work again. So, that is why if there is a mechanism by which you can refill it, you can take out the bad ones and you can take the new ones. So, therefore, that means you are fueling the cell, and therefore, you can drive the cell. So, you can fuel the cell and ultimately drive the cell, fuel the cell or drive the cell. So, this principle, I mean this idea was first demonstrated by Grove in 1839. First this idea was implemented, it was demonstrated by Grove in 1839. The idea was so old that in that time people could think about that whether we can fuel the cell Okay. So, it was, I mean, at that time it was known that water, I mean, as a result of electrolysis of water, water is decomposed, electrolyzed to form H2 and O2. Okay. So, what group tried was to recombine two, you know, these two, I mean these two, recombine means recombine water and I am sorry, I mean hydrogen and oxygen to form water. Okay. So, so basically these two gases are allowed to recombine in a specific fashion. So, basically it will be the reverse of electrolysis. So, reverse of, okay, reverse of electrolysis. Okay. So, so recombine H2 plus O2 to produce water, and this will cause a potential difference, okay, against two electrodes dipped over there. So, a potential difference will be there across two electrodes present. Okay. So, what is happening over there? Again you need to consider anode process and anodic and cathodic process. So, anode process is H2 gas that gets you 2H plus twice electron, and corresponding potential is 0 volt, because H2 to H plus, remember this standard hydrogen electrode case, that where electrode potential at all temperature is assumed to be 0. So, that is the concept. And cathode process is half O2 gas plus twice H plus twice electron, that gets you water, and here E naught is equal to plus 1.23 volt, plus 1 2. You remember, if you think about the reverse reaction, then it is minus 1.23 volt, which we already have used many times. So, what is the net reaction? Net reaction is H2 gas plus half O2 gas, that gets you H2O liquid, where E naught is 1.23 volt. Okay, so this is the basic idea. Then in 1959, first working hydrogen oxygen based, first working hydrogen oxygen based fuel cell was invented by Francis T. Bacon. Okay. Now, alkaline electrolyte, nowadays alkaline electrolyte is used. Alkaline is used in modern cells. Now, what is the reaction? Anode reaction. Anode reaction is H2 gas plus 2 OH minus gets you 2 H2O plus twice electron, again E naught is equal to 0 volt. Then cathode reaction, half O2 gas plus 2 water plus twice electron, that gets you 2 OH minus, E naught is equal to plus 1.23 volt, and net is the same reaction. Net reaction is H2 gas plus half O2 gas, that gets you water, with E naught equal to 1.23 volt. So, what is the pictorial representation of this? So, pictorial representation will be like this. It is like this, that in one side you put oxygen, in the other side you put hydrogen H2 fuel. Okay. You have porous electrode, so that this hydrogen can diffuse in, and also oxygen can diffuse in. This is a porous electrode. So, porous electrode, and this one is anode, this is cathode. So, minus, this is plus. If you put this against some external load, then electrons will flow this way, current will flow this way, the other way, and this anode reaction will be 2 H2, that gets you 4 H plus 4 electron. Cathode reaction will be 4 H plus O2 plus 4 electron, that gets you water. That means it is alkaline. So, therefore, NaOH and H plus will be moving this direction. So, this H2 will diffuse in, and then it will be converted to H plus, and then it will move from this direction to this direction. So, here you input of air, that means O2, and here excess of air and unused O2 is coming out. So, this is a porous cathode, this is porous anode, and this porous cathode, porous anode, and the net process is this. Okay. So, only problem is that already I have discussed at one point that this oxygen consumption, this oxygen consumption process, it's a slow, kinetically slow process. So, kinetically slow. So, that puts a problem for problem against its efficient functioning. Okay. So, therefore, this porous cathode, if we replace this porous cathode with some expensive platinum cathode, then it has been found that such problems are mostly eradicated. So, only problem is that platinum is a costly metal. So, it will increase the pricing of this device, pricing of this cell. So, therefore, these are this is one of the important drawbacks for this particular fuel cell. So, what is happening, that you are fueling, and this is the this is the you know excess of air or oxygen, this is taken out, and also the reaction product is water. So, you see that as I when I started discussion with this, then I was telling one thing, that if you can remove the reaction product and if you then feed the cell with new set of chemicals, I mean the same chemicals, but new batch of chemicals, then it will be fueled. I mean this you are fueling it, okay, you are fueling it, and then after this reaction is taking place, again what will happen, you take out water. So, this way you keep on doing. So, you are fueling, you are gaining energy, and then you are taking out the reaction product, this way this will continue. So, therefore, only thing is that only problem is with platinum, but you see this oxygen, it is readily available from air. Hydrogen fuel you can get from electrolysis of water, acidic water you can get. So, theoretically its potential difference is its potential difference is about 1.23 volt at 298 Kelvin. But it has been found because of several other problems, drawbacks, and that also depends on the pressure of this air, then hydrogen, and then nature of the electrode, and so if these are considered, then it has been found. I mean, if you consider all this, if those are the those create trouble, then you will be it means actually what you get is that open circuit the voltage is 1 volt, around 1 volt, it is not more than 1 volt, and if you put load with load, this reduces to about 0.5 to 0.8 volt. Okay. So, this this is called a fuel cell. So, you are fueling it and you are getting energy, and it is continuing, means you are continuously fueling and you are getting the energy. So, that way it is happening. Okay. So, that completes the basic discussion with respect to the fuel cell. Then we will move on to another important issue that is called corrosion. Corrosion, that is, corrosion means because of corrosion, suppose you have a shining iron material, iron pot in your hand, and say you are not using that for long time, and you are keeping that nice container, iron container, outside is shining. Okay. You are keeping it here means in open air, that maybe which the problem is more during rainy time. So, you will be finding that after some days this this shining color, shining nature of this material, this pot is gone, and some spots come, brown spots come, which are called the rust. Okay. So, therefore, the deterioration of this material is there, and this happens particularly if the place is is having damp or during rainy time. But during winter time, the situation is little better, that the probability or the possibility that the materials will lose its luster as a result of rusting, that is reduced. Or if you keep in airtight container, or maybe if you keep in a container, material in a container, just removing the removing this moisture by keeping some hygroscopic material inside, that you will take moisture like calcium oxide or like that. So, then this probability or this chance of this corrosion will be reduced. So, basically it is the chemical reaction that is taking place at the smooth surface of various metals. Okay. So, So, technically corrosion means spontaneously the metals will return to their ore condition. Ore condition means as if you are returning back your metal to to their ore condition, that means to their compound state. Okay. So, electrochemical corrosion means this corrosion as a result of chemical reaction at the surface, and some small cells are formed, and the net free energy for the cell reaction is such that the process is spontaneous, and ultimately the end product is that the surface is corroded. So, therefore, electrochemical corrosion is very important. So, basically M to M plus electron. So, this is the process. So, and this is facilitated in presence of suitable electron acceptor. That means, this electron is free. If electron is accepted by something, then the process will be facilitated. That metal will form M plus, and therefore, smooth surface of the metal will get corrosion. So, in presence of this is facilitated by the presence of suitable electron acceptor. Okay. And this is also known in corrosion language that it is these are called depolarizer. Depolarizers. Sometime what happens that a thin film of water or moisture, a thin film of moisture that is moisture which is in the form of adsorption, adsorbed moisture can be very dangerous in respect of corrosion, that it will promote corrosion of the metal surface. So, basically the corrosion system, the system where corrosion is taking place, that may be regarded as, that may also be called as, it may be, so corrosion system or the system where corrosion takes place can be regarded as a short circuited electrochemical cell in which the anodic reaction could be say for example, metal to say metal 2 plus aqueous plus 2 isoelectron. The celebrated example may be iron, because the problem of corrosion is mostly with iron, because we complain mostly about corrosion. I mean the effect of corrosion, or I do not like it. I mean that people does not like it, that okay, it is corroded, so it looks bad. So, mostly that is involved with this iron. So, iron 2 plus equated plus 2 isoelectron, and the cathodic processes may be, and the cathodic process. So, this is an anodic process, that is at as if it is an anode reaction. So, anodic process, and corresponding cathode reactions could be H plus electron, that is an acceptor that gets to half H2 gas. So, this is an acceptor. So, therefore, in presence of acid, that electron is accepted, that means the electron which was liberated from the metal while it produces this M plus or M2 plus, that will be accepted by H plus to produce water, to produce hydrogen, or maybe M2 plus twice electron, then it gets you M solid, where M is a metal. Okay. So, corrosion is a two step process, as I was discussing, that one part is a cathodic part, another part is an anodic part. So, cathodic part means metal will lose the electron, and someone will be there to, someone means some other agent will be there to accept the electron, so that the driving force of the process will be in forward direction. So, corrosion is a two step, it is having two steps. Say for example, if we talk about this iron corrosion, then first one is that in presence of moisture, a film of moisture, what happens that the surface is coated with moisture, means the surface, metal surface is having adsorbed moisture on it. So, therefore, first step is iron, that makes iron 2 plus ion, ferrous ion plus twice electron. So, it dissolves, okay, and the metal becomes, excess negative charge because of this one. It is having excess of negative charge. Suppose if there is a mechanism that by which you pump this electron out, then the process will be more favorable. But if there is a mechanism by which you put more electrons from outside, or if you make a situation that the environment is such that this particular system is reluctant to remove this electron from here, that means once the electron is accumulated over there, it is very difficult to get rid of that, then the process will not be very favorable. So, iron will try to, iron 2 plus or iron will try to remain in its elemental state. Okay. So, what happens, and second step is, so corrosion will continue smoothly as the depolarizer or the electron acceptor is removing that this electron. Okay. Say for example, acid, as I mentioned, acid, so 2H plus twice electron gets you H2, or like this is A, B means, like say for example, if you have a more noble metal, so metal ion. So, what will happen, Cu 2 plus, then plus twice electron, that gets you Cu. Okay. Or maybe even if there is oxygen, situation is like if there is oxygen and this oxygen is available in air. So, if there is oxygen, O2 may be a problem, O2. So, O2 can again create an additional trouble like this, plus 4 water, that produces 4 electrons plus 4 OH minus, okay. And this 4 OH minus will combine with, this OH minus will combine with iron 2 to produce this hydrous ferrous oxide. This will produce hydrous ferrous oxide, which is called the rust. So, it will look bad, the surface will look bad. So, then how to get rid of this? How to get rid of this means, so these are the possible situations that you have, like problem is that you have a copper sulphate solution, that somehow copper sulphate solution has spilled on the iron surface and little bit of moisture is there. Then what is going to happen? Thing is that the tendency of copper ion, because this is in the lower side, it is easy to reduce than this one. So, this one will be difficult to reduce. So, the thing is that this reaction will proceed, at the same time this reaction will also proceed. So, metal to metal ion and here metal ion to metal, this coupled process will take place, because the net thermodynamics of this process is very favorable. So, that is why if more noble metals are present, then it is a trouble. More noble means more noble than iron or the corrosion of the concerned metal. Okay. And also suppose if there is a spillage of acid, then it will induce more corrosion. Suppose you have a little corrosion, if by some means some acid has spilled onto the little corroded surface, then the corrosion will be more efficient, and then corrosion will spread all over the surface of this iron. So, this nice shiny surface will be damaged. So, therefore, corrosion is a real trouble to us. And at the same time, suppose you can paint the iron, the shining iron surface with the help of a specific paint. The point is that so it is, this paint is on the surface of this metal. So, if your paint is not that good, then what will happen, when water will fall on the surface of the paint, it will penetrate and go inside and will stay in between this iron surface and this paint coating. So, that means it is practically a thin coating of moisture, water, and if that moisture stays for a long time, what will happen? So, this surface, this metal surface on which this nice coating of this paint is there, so in between that there will be corrosion. So, when corrosion is there, this hydrous ferrous oxide will come, will be produced over there, and this hydrous ferrous oxide is basically having more volume. Okay. So, it will have larger volume. So, it will just bulge out of the surface. So, therefore, it will look that some, as if some blister looking thing on the surface of across the paint. Okay. So, therefore, if you give a little pressure, then it will break and then paint will also go, and ultimately the good look of this painted stuff is lost. So, therefore, it is very important that if you use a very efficient material, very efficient in the sense that if you use a water repellent material like Teflon or similar material, then the possibility that this water moisture will go inside and reach the metal surface, that will be reduced. I am not telling that it will be removed, but it will be reduced. Okay. So, that is why covering the metal surface with appropriate thing is very important. Okay. Or maybe in some cases oil, if you have oil oil coating, that is also good, but the point is if oil is having some moisture, then it is a real difficulty. Okay. So, sometime if you cover the surface with thin oxide, then that will inhibit the anodic dissolution process. Okay. So, anodic dissolution process means M to M N plus, this anodic dissolution process is inhibited if you use this oxide film or oxide paint. And if metal is now the point is, if the metal is this metal surface say on which this corrosion is taking place, if this is that one is little biased with negative potential, or if it is having excess of negative charge, then the tendency that an additional metal atom, that it will lose an electron and give it to this metal surface and it will dissolve, this tendency will be reduced, because already the metal is having excess of negative charge. So, dissolution will be difficult. In this way, dissolution will be difficult. So, if you have a coating onto this metal surface, the metal, the coated metal, the metal with which you will coat the iron surface, say for example, if it is more reactive than iron, like say for example, if you have a coating of zinc metal on iron, then zinc will tend to get when zinc itself will tend to get corroded, because with moisture, I mean, it will just become zinc 2 plus twice electron, and this twice electron means this twice electron will stay onto the metal surface. Metal means originally the iron surface. So, then what will happen, that iron to iron 2, this process will be inhibited, because this is already having excess of negative charge. So, therefore, so the I mean, basically the metal sheet I mean, iron, say for example, iron sheet will have negative charge on it because of this reaction, because it has dissolved. So, it has left 2 electrons onto the metal surface. So, therefore, local, I mean, corrosion, which may be a local process, that local process will be sluggish, or in some cases it may be reduced to a greater extent. So, that is why, you know, coating of like zinc coating on this iron sheet has been found in many cases. Okay. So, that is why, so these are the ways by which you can, I mean, you can reduce the extent of corrosion, but corrosion is really a problem, because I mean, in atmosphere you have oxygen, in atmosphere you have moisture. Okay. Moisture, the amount of moisture may be less or may be more, but it is there. So, if you keep on exposing your metal surface, this metal, if it is a reactive metal surface with respect to this moisture, then what will happen, that a thin film of air will be there, and that will create trouble. So, it is a real difficulty you know, in day to day life. So, therefore, like, so things will be corroded, and it will get rust, and if there is rust, then the longevity, as far as the longevity of the substance, like you know, material like say for example, so, you know, like if it is car or motorcycle, or maybe iron made substance, things. So, all will be eventually damaged if it is exposed to moisture, or suppose if it is kept in open sky, and during, you know, rainy time, it will get, you know, water, and then you will be finding that after rainy season is over, it gets a thin coating of this brownish rust on it, and if you keep it for a longer time, then it will continue to increase. So, that is why you need to scrap it, and then probably with appropriate oxide coating, or maybe appropriate metal coating like zinc can prevent its further damage, and maybe life of this thing will be you know, increased. So, while summing up what we have studied in this particular piece of lecture, that we have tried to sum up most of the things that we already have studied over here during the earlier lectures. Now, in this piece of lecture, we have you know, talked about this corrosion, and also we have talked about fuel cell, which is a very important concept. And so this fuel cell, we talked, I mean, the basics of that has been talked about, and also the corrosion, that is it's a problem as far as electrochemistry is concerned, problem in the sense that materials are getting damaged due to this electrochemical, you know, processes on the surface. So, how this can be eradicated, whether it is fully eradicatable or not. So, that is a question, but at least we can try to minimize it. So, this much for today. So, in the next lecture, probably that is the final lecture in this electrochemistry session, we will take up some numerical problems along with some questions. We will discuss some questions and possible answers to make you acquainted with the possible, you know, questions may come in your mind. Okay. So, and also possible numerical problems that you may attempt with while discussing or while reading some of the books that is available in market. Okay. So that will be taken up in the next next lecture, possibly that is the final lecture. So till then, have good time. Thank you.